Okay, the purpose of this is to show you how to use Vivado to do a VHDL program. So this is not going to include microplays. This would be for part one of your lab. So the first thing you're going to do is click on Create New Project, and then click Next, and then you're going to give your project a name. I'm going to call it VHDL example. You can call it Lab 1 or Lab 5, something like that. Next, and then you're going to select RTL project, click Next, and then the rest of the stuff you're going to click Next to. The only thing is you need to make sure that the target language is VHDL and the simulator language is VHDL. Other than that, you just click Next, and then when you get here, what you want to do is you want to select Matrix 7, and then you want to select the CSG324 package, and then -1 here, and then you want to make sure you select this one here, and click Next, and finish. And it'll create the project. Once that's done, now what you need to do is add some design sources. So you're going to right click on here and put add sources. Make sure it's add or create design sources. You can hit Next, hit create file, and then give it a name. I'm going to call it adder because I'm going to do the adder. Hit OK, and then leave everything default and hit finish. You can just hit OK here, say yes. It'll create the source. So just to save some time, I'm going to copy and paste my code into there. Alright, now that I have my code in there, the next thing I'm going to do is create a simulator source. So I'm going to right click on Sim, put Add Source, make sure it says Add or Create Simulation Sources. Click Next, create a file, and I'm going to call this adder testbench underscore TV. Click OK, hit finish, and it'll create a test bench. You just hit OK here. Yes. And it'll create a test bench under here. I'm going to go ahead and open it, and then I'm going to copy and paste my test bench code into it. In your case, you would write the test bench and the adder. I already have the code, but for your lab, you're going to have to write for all the different combination of logic. Now we want to run a simulation. I'm going to go here and click on Run Simulation, run Behavioral, and it will run the simulation. Once that's done, you have the waveform. You probably want to get full view, and then you can see all the outputs from the test bench, and you can see the different results here. Next, what you want to do is you want to go back to Project Manager, and under Constraints, you want to download from Titanium this constraints file. So let's go ahead and download that, and then we need to store it into our project. So I'm going to click on this. And then I'm going to go into, if you're using Windows, it's going to be in C drive, users, whatever your username is, mine's gfollow. And then wherever you have your projects, I have it in a folder called Vivado Projects. And then I'm going to put it in VHDL example, and I'm just going to put it here. And then inside Vivado, we're going to go here, right click, put Add Sources. Make sure it says Add Create Constraints. And then we're going to add that constraint file. So then you have to navigate to that same location. So it's, in my case, C drive, users, gfollow, Vivado projects, VHDL example, and then I'm going to add the XDC file and hit finish. And it'll add the constraints file to it. So what this is going to let you do is it's going to let you associate the different ports. So in my case, it's A and B. These are vectors, by the way. So you have to add one thing for each bit, and then also the carry in, and then it also lets us associate the outputs. So for example, if I want to add A and I want to associate it to the switches on the board, I have to, since it's a 4-bit input, I have to uncomment 4 of these, and I have to switch this to A. And it's case sensitive, so you need to make sure if it's lowercase a, like in this case, you have to make sure it's lowercase a here. And then I'm going to add the B's, so I have the B's is a 4-bit vector, so I have to do 1 for each bit. So I'm going to make this B0. B is 0 based for standard logic vector. And then we have a couple more inputs. We have carry in, which is 1. We have one more input. Carry in is one bit. So I'm going to use the switch 8 to be my carrier. Now we have to assign the outputs. We have a carry out, which is 1 bit, and then we have sum, which is 4 bits. So I'm going to make that on the LEDs. I'm going to make the 4 least significant bits my sum output. So let's change this to sum, 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 sum. And then I'm going to make my carry out the most significant LED 4. Alright, and then let's just call carry. Yeah. Alright, so now I associated the switches to my ports, input ports, and my LEDs to my output. Next thing we want to do is run implementation. So this is going to take a while. So go ahead and click on it, and it will take several minutes to do. Okay. And then it'll queue it and start the synthesis. Once this is done, this will indicate that it's finished down here. And also up here you can see an indicator. Okay, once this is done, you get this window. You don't have to open the implementation to implement the design. It's just going to show you how it gets laid out. What I typically do is just do generate bitstream because that's the next step. So go ahead and do that. This will take a few minutes. So again, you can look down here. It'll have an indicator, and it also say up here when it's writing bitstream. So just give it a few minutes. Okay, once this is done, you get this window. You don't really need to do this, but if you click on it, it'll show you the implemented design, which just shows you how it's going to lay out your design on the FPGA. So I'll go ahead and let it do this. It just shows you where it's going to lay it out. But we're not going to get to that detail though. Okay, so the next step you want to do is you want to open the target. If you click on this, if the auto connect is still highlighted, you want to click on that so it connects to your target. You have to have the FPGA port plugged in at this point. Then the next thing you want to do is program it. Once it's connected, you should get a little sub-menu that shows you the target. Just click on that. This window will come up. It should be auto-populated with the bit file. If it's not, you're going to have to find it, and it's usually in your folder under your folder name .runs implementation.bit. Hit program, it'll program the board, and now the program is on your device. Okay, so now that you have the device programmed, you can use the switches. So if you look down here on the bottom right hand of the screen, I'm showing the FPGA board. So you use these switches, and then your output will be shown on the LEDs. So these 4, I kind of did it backwards, but these 4 switches will control A, these will control B, and then this would be your carry-in. I probably should have done A, B, and carry-in, but I did it this way. So A, B, and then carry-in. And then these 4 LEDs will be your sum, and this will be your carry out, your carry. So I brought up the simulator here on the screen, and I'm just going to pick one example. So in this example, we're going to make my A input a 12. So if you look on here, I have 8 plus 4, so this gives me 12. And then my B is going to be a 4. So if you look at these 4 bits, I have the third bit 2 up, so this will give me 4. And then it also has a carry-in, which is this switch. And my output should be my carry out should be high, which is shown here, and my sum should be 1. So it looks like I'm getting the right output from this. And what's nice about the switch is you can kind of go through here and try different combinations. So feel free to try that example.